This is the retake video for the test of sections 2.1 and 2.3 in pre-calculus, and these are the steps that you need to take for the retake. Number 1, watch this video, take notes of everything, write down the problems, write down the work that was shown as you go through it. For number 2, go back in the notes and highlight the problems that are similar to the test problems. Number 3, redo that review assignment. Take your time. Make sure you understand the concepts. Pay particular attention to any problems that you may have had wrong on the test. And then the deadlines. Contact me by December 8th with 1 through 3 completed, and then I'll check. I'll probably have you send me a little video of you flipping through everything that you've done. And then the next day, which is December 9th, by 1:45, you should be starting, if you haven't already, started the test, and get that taken before the 2:45 deadline, which is the end of the school day. And no exceptions. Remember, the only way that you're eligible for all of this is if you had all the homework in prior to the test. So now, the test that you took started with question 3 because you had questions above that that were, am I going to have integrity while I take this test, etc. So this one says, if the following is a polynomial function, then state its degree and leading coefficient. If it's not, then state this fact. And I know that it's not right away because I see that it's a fourth root. So it could be written as the quantity 16x to the 16th plus 81x to the 4th to the 1/4 power. And that 1/4 power right there is the issue because we can only have whole number powers to be a polynomial function. So this one is not a polynomial function. Now, if some of you were thinking, but I can take the fourth root of 16x to the 16th. I can take the fourth root of 81x to the 4th. What you forgot was those are added together. So that means if you're going to take the fourth root, you have to take the fourth root of all of it at one time. You can't separate that into two separate terms and use it that way. Because of that plus, it works differently. You have to think, what would I put in each of those 4 parentheses? It has to be the exact same thing that would multiply to give me 16x to the 16th plus 81x to the 4th. So it's that plus that really mucks up the works there. So anytime we don't have a whole number for our exponents, then we have to say, no, this is not going to work. All right, question 4. Now this one was the one where there were several versions. I think we had 4 different completing the square problems that were shuffled around in there randomly. So with this one, it's f of x equals negative 7x squared minus 14x minus 10, and we're going to use the completing the square to get this in vertex form, which would look like this. Right there, and then identify the vertex and the axis of symmetry. So first things first, I'm going to take that f of x off of there and make that y. So this one is y equals negative 7x squared minus 14x minus 10. Now, the first 2 steps are interchangeable. We have to divide by negative 7 because you cannot complete the square with anything other than a 1 in the A position, and we have a negative 7 there. We also have to move the 10 out of the way because that 10 is not a perfect square. And usually it's easiest to move the 10 out of the way first by adding 10 to both sides, and then divide everything by negative 7. Now at this point, it is also usually easier not to have that negative in the denominator. So instead of down in the denominator, go ahead and distribute it to the numerator. So for some of you, that was the step there that messed you up because there was a negative in that denominator. And now we have to figure out what number needs to be added to both sides to complete the square. And with this one, we've got a b value of 2, and we know we're supposed to take b over 2 and square it. So 2 over 2 squared is 1 squared, which is 1. But what we do to one side, we have to do to the other. And this, like I said, is where people made mistakes. And that's because if you had a negative 7 for your denominator, then you had to use negative 7 over negative 7 to represent positive 1. And some of you didn't do that. You used a 7 and a negative 7, which would have been a negative 1, subtracting 1 from both sides. So, like I said, it's easier to put the negative in the numerator, change the 1 to 7/7, write your perfect square trinomial as a binomial squared, realize that you have a common denominator over here, so we'll have negative y minus 3 over 7, and then start moving things back. So we could go ahead, you could move the negative down with the 7 now, and you wouldn't have any trouble, but I'm just going to go ahead and move things back as they are. So I'm going to multiply both sides by 7, and then I'm going to add 3 to both sides, and finally divide all terms by negative 1. Now, I say all terms because there are actually 3 of them here. So y equals negative 7 times the quantity x plus 1 squared minus 3. And last but not least, I probably better name that f of x again. I didn't take points off if you left that as y. This was our first, everybody has to take this test online test, and so I'm sure some of you were a little bit rattled. And normally that would be something that would lose you a quarter of a point, but I did not take any points off for that on this test. Now, the follow-up, which some of you forgot, you did all this work and you had some great answers. The follow-up was, where's the vertex and where is the axis of symmetry? Well, the vertex is going to be a vertical line through, I'm talking about the axis of symmetry already. You want to have your axis of symmetry be the vertical line through your vertex. So no matter what, the first thing you're going to do is figure out where that vertex is. And remember that h is always the opposite of what we see in those parentheses, so it'll be negative 1, negative 3. And then x equals negative 1 will be our axis of symmetry, and that's a line. So you have to have the x equals on there, x equals negative 1, in order for that to get you points. An equation for a line. All right, that one would have taken you a little bit of time there. Well, it says 5, so we'll go with 5. Write an equation for the quadratic function whose graph contains the given vertex and point. Now, they gave me the vertex, and that's a huge hint because that tells me I should be using my vertex form. And I see my vertex down there at 2, negative 3. A little hard to see with those small numbers in there. So that's my h and k. So y equals a times the quantity x minus 2 squared minus 3. And what I don't know here is a, and I need that. I can't write the equation without a. But I realized that if I had something to put in for x and y, then I could find a. And that's why this other information is here, and that is the other point that they have marked for us there is 4, 1. So you have to find a, you have to. And you can't use anything like slope because quadratics don't have slopes. So you have to put in the x and the y pair. And then do the math. So order of operations, 4 minus 2 is 2, 2 squared is 4. Then we'd add 3 to both sides and divide by 4. And a ends up being 1. But without showing that work, I can't give you much for this problem. I have to see that you understood what a was. And now we'll go ahead and write it. And it did say quadratic function, so I'll call it g of x. Our a value is 1, so I don't need to write it down. I'm going to because I want everybody to see that that a was important. And then we have the quantity x minus 2 squared minus 3. But your last step would be get that 1 out of there so that this is simplified. And that's another thing I would not have taken off for if you had left it on the test, was that little 1 that you see there. That would have been just fine, as long as I could find it in your work that you had actually done the algebra to find it. Oh, wait a second. There should be a big word problem down here somewhere. There it is. The big, huge word problem. Solve the problem using the vertical free fall motion formulas. So we see S of t and V of t, where t is time in seconds, and gravity is about 32 feet per second squared and about 9.8 meters per second. So some people, not very many, a couple of people chose the wrong one. What you have to do is look at the labels that are involved in this problem. And I see that we're talking about feet per second. That means I have to use 32 feet per square second in order to do the math right. I have to have the same units here. So I should not be using that 9.8 at all as I do this problem. Alrighty, the projectile is thrown upward so that its initial velocity is 70 feet per second from an initial height of 7 feet. So we'll have to go back and put those in, and that's the first thing it wants. Find an equation to model the height of the ball after t seconds, then identify the maximum height of the projectile along with the number of seconds required to reach that height. Then, finally, determine the projectile's velocity upon impact with the ground. Alrighty, so let's figure out what all this stuff goes. Like it says, t is time in seconds, and we've got our g value there, so let's get everything in. S of t equals -1/2. Gravity was 32, plus initial velocity was 70. Oh, I didn't put the t squared in there. There we go. -1/2 times 32 t squared plus 70t plus 7. And then, of course, you would figure out what you had there. And -1/2 times 32 would be -16t squared plus 70t plus 7. And I was just thinking here, I think this was another one. Yes, we had 4 different versions of this. So you may not have seen these exact numbers, but you had a problem that was incredibly similar to this. So we've got that. And we realized, well, the next thing was what they want in the blank here. They want to know the maximum height of the projectile. Well, the maximum height is at the vertex. And that equation is in standard form. So we should use x equals -b over 2a to figure out what the x-coordinate of the vertex is. So -70 over 2 times -16, -70 over -32, and that comes out to be 2.1875. So that's the x-coordinate of the vertex. And I'm not going to round that because I don't want a rounding error. I want the exact answers when I get to the point where I'm answering those little spaces in there. So I know I have to put this answer back into the formula. And if I round it right now, I'm going to have a worse rounding error when I get done because I have to take 2.1875 and put that back into the equation. So I want S of 2.1875, -16 times 2.1875 squared plus 70 times 2.1875 plus 7, and that comes out to be 83.5625. And then we have to figure out, okay, which is which here? Well, the 2.1875, that was the x. So now I can round it when I put it up in my little spot here. So 2.188 seconds, and the height was 83.563, and this was in feet. Now, Finally, determine the projectile's velocity upon impact with the ground. So here's what's happened. It's gone up and it's come back down. And I need to know right here, what is its velocity? Well, to do that, I'm either going to have to try and factor it, which it does not look like it would be pleasant, negative 16t squared plus 70t plus 7 to find the zeros, or do what we did in class, which is get our graphing calculator going, which I'm going to stop and pause this and get my TI-84 Plus up here for the smartboard. All right, so if you take a look up here now, you're going to see that on the top equation, y sub 1, that's the only one I have active, and that's because the equals has a little black rectangle about it, around it, and there's our negative 16t squared plus 70t plus 7, just with x's in it. So I'm going to go to the window, and because we already knew where the vertex was, and it was at the ordered pair 2.1875, 83.5625, I just went with 0 to 8 and 0 to 100. And there's the graph. But I need to see the 0 over here. I need to know where that is, because I'm going to write that little formula for velocity, and I need to put in the time that it hit. So I'm going to put in a couple of negatives in my y's so I have a little working room. I'll maybe try negative 20. And then I'm going to call on my little cursor blanky, second trace, number 2. And above it is to the left, enter. Below it is to the right, enter, enter through guess, and we get 4.47283132, and we would round this one because now we're working with a calculator and we're going to put a calculator number in. We have no idea whether or not it stopped at the end of 32. In fact, almost all of the time it doesn't. So we would round that to 4.473. And now we have to figure out the formula for the velocity. Well, way back up here, it says v of t equals negative gt plus v sub naught. We already know what gravity was. That was the 32. So negative 32t plus, we know the initial velocity. They told us that was 70. So our little formula, v of t, will equal negative 32t plus 70. And since we want to know when it hits the ground what the velocity is, we have to put in that time of 4.473. And that came out to be about negative 73.136 feet per second. Now, because I rounded to 3 decimal points, and that's what we're supposed to do anyway, but some of you may have tried to put what you thought was the exact number in from the graphing calculator. So if you were off at your thousandths position there, I didn't take any off. And then if you wrote in English 73.136 feet per second downward, then you didn't need to have the negative on there either. So that one was kind of a monster. And like I said, 4 different versions out there, and you had one of them, and just want to finish off all of those blanks for that problem. So really, you didn't need your calculator until you were trying to figure out what the velocity was. And unfortunately, some people actually forgot to do the velocity. You had the rest of the problem done, but you didn't do that velocity piece. Alrighty, the next one, we're using regression to solve the problem, round numbers to the nearest hundredth. So I already put those into the graphing calculator here. Under Stats Edit, and you can see I have those numbers in List 1 and List 2. So it says, use regression to solve it. The ages and lengths of several animals of the same species are recorded in the following table, and I'm looking, well, where on earth, what kind of regression do I need to do? Well, it's underneath the table. Use linear regression to predict the length. So, with all this information in here, it's stats, arrow to the right once for calculate, number 4, but I have this information in list 1 and list 2. So I hit second, number 1 for list 1, second, number 2 for list 2. And I'm not going to be storing anything. I'm going to go right to calculate. And there it is. And we would write that down to 3 decimal places. So y equals 1.087x minus 2.442. All right, so I stopped it and wrote that down. And now we have to finish this one up because it says use linear regression to predict the length of a 35-month-old animal. And we can see from the table that that was our x value. So we have to put a 35 in for x. And then they had us rounding this to the nearest hundredth, and it came out to 35.60 inches when you do that. So this one, linear regression, but a follow-up question that you had to finish off, and that was a multiple choice. Then question 8 says we've got a cubic regression problem. We just want to fit the curve, round to the nearest hundredth. There's no follow-up with this one, so we make sure we get these into our graphing calculator, stats, edit, and I have those, well, there's not very many of them, just the 4 ordered pairs in there for list 3 and list 4. So stats, but this time when we go to calculate, we have to find cubic regression, which is number 6. So you can either just hit 6 or arrow your way down. And like I said, I need to use list 3 and list 4 to calculate this one. So it gives you the setup, y equals ax cubed plus bx squared plus cx plus d, and you just have to put them in the proper positions. So y equals 0.283, rounding to 3 decimal places. Nope, this one said hundredths. So y equals 0.28x cubed minus 4.35x squared plus 24.97x minus 33.4. And it was multiple choice, but let me go ahead and write this down. Oops, not with green. Too close to the edge. There we go. And that one, again, that was multiple choice. So you just had to match that up with what you found. Alrighty, the next problem. And like it says, you're going to graph the function. So there's a graph there. Now, I know it's silly to say this. Somebody didn't graph it. It's like that's the first thing that it says is graph the function. And you did all of the groundwork by finding, the multiplicity, the x-intercepts, all of that stuff, but you didn't graph it. And I can't give you the points for graphing when you do that. So make sure when I sent this information out, I said, have some graph paper handy. It's a test. You want to make sure that things are looking nice. So graph the function identifying all of its extrema and x-intercepts, stating the multiplicity of each zero along with the description as crossing or tangent, and then the y-intercept. Now, if I could see your y-intercept on your graph, then I didn't take points off for you not writing it down. But our x-intercepts all come from the zeros of what we see in the parentheses there. So for 2x plus 1, our 0 would be negative 1/2. And we don't, when it has a first power for it, when it's linear, we don't say it has multiplicity. But if you wrote down 1, I didn't take off for that. And because that is an odd number for multiplicity, it's going to cross. Then the next 0 would be -1. And again, power of 1 crosses. The next 0 would be 2. Power of 1 crosses. And then the last one is 1, but that one has a power of 2. And that means it's tangent. It's going to bounce. So those are the x-intercepts, the multiplicity, and the behavior. But it also said that we had to give them the y-intercept. And like I said, the y-intercept is going to come from what we graph. So we know at -1/2 is going to cross. At -1, it's going to cross. At 2, it's going to cross. And at 1, it's going to bounce. So there it is. We also know 1, 2, 3, 4, 5. Power of 5. So we know that this is going to be almost straight down and this is going to be almost straight up because that's the end behavior. But what we don't know is how far up, how far down everything is going to go. So what we have to do is figure out where those local maxes and local mins are. And it turns out there are 2 of each. Now, on the test, I had written them in that format just to remind you what was going on. Some of you only put 2 of them down. You have to have all 4 of them. Now, I don't think it was because you didn't know how to find the local max and the local min. You just didn't take the time to find the other 2. So this one was a local max of 1.089 at x equals -0.795. So that's the reason that I'm not showing you how to do this in the calculator, because like I said, I actually think a couple of people may have actually typed this in wrong in their calculator, and that's why they only saw 2. But you need to know that those turning points where it was increasing and it's suddenly decreasing, or decreasing to suddenly increasing, those are really important, and we have to use the graphing calculator to find those. Local min of -2.036 at 0.073. Local max of 0 at x equals 1. And a local min of -1.753 at x equals 1.721. And then just so that we have at least 3 points in our table, really having the maxes and mins is going to do a lot for us. But what we had to have was that y-intercept. So like I said, if you didn't have a table, but I saw that you actually graphed at 0, -2, then I gave you that. This is hard to do with this big thick marker here, but those would have given us our local maxes and our local mins. So now we've graphed it and we identified its extrema, that's the maxes, local maxes, and local mins, and the x-intercept stated the multiplicity of each, told whether or not it was crossing or it was tangent, and on my graph and in my table I have that y-intercept. So if there is anybody who believes they were not finding the local maxes and local mins properly, we could do a little Google Meet on that. But like I said, I think more often than not, it was just you saw 2 slots and you just put 2 answers down. So this is what I meant by the fact that I had put this down here. Notice that it just says reminder. You know, that was so that you would be thinking about the fact that the y's are what's really important. We're finding the heights. All right. Question 10. Describe the end behavior of the polynomial just using our limit notation, which is how we describe end behavior anyway. And you did not have to go through and do all the multiplication on this one. Here's what you needed. You need the fact that it's negative, and this is x to the first, and x squared. So x to the first times x to the first times x squared, that's going to give you a negative x to the fourth, which is parabolic, and it goes downward. So the limit as x approaches negative infinity for f of x equals negative infinity, and the limit as x approaches infinity for f of x is also negative infinity. And that one, I believe, was multiple choice for you. Yes, it was. So you just needed to know what would the degree be, and is there a positive or a negative leading coefficient, and then you can answer that. So you didn't need to multiply all those out. Question 11. Find the zeros of the function. Well, that means factoring. That's always the best way to figure out where the zeros are. So I don't want f of x there anymore. I want 0, because that's what I want to know. Greatest common monomial factor is an x, so take that out. And then it is probable that we will be able to continue on factoring here with a 3x and an x being the only options for 3x squared. We just need to place our factors of positive 2 so that they'll end up giving us a negative 5 in the middle, and that makes you think, oh, so they both have to be negative. So it's a negative 1 and a negative 2. Well, let's see. If I put negative 1 here and negative 2 here, outside times outside gives me negative 3x. Inside times inside gives me negative 2x. And I have it. So my zeros are at 0, 2/3, and 1. And that one was also a multiple choice. But you had to show your factoring. I mean, like I said before, each of the steps from these problems is how you get a point. So you had to show your factoring. Then the next one. Use a graphing calculator to approximate the real zeros of the function defined by f of x, and there's that little monster right there. So we want to figure out what the zeros are, and I have that one already loaded up in here. Let's see, it is y sub 3. And so for y sub 3, I'm going to turn this one off, get this one turned on. There we go. Try zoom 6. So I can see the 2 zeros. I just have to figure out where they are, and that's, again, using the cursor. So second trace, number 2 for Blinky. I'm going to need to be above it to be to the left and hit enter. Below the x-axis to be to the right and hit enter, and enter through guess. So this one to 3 decimal places 0.270, 0. And then the other one, second trace, number 2, and here's where they switch positions. Below it is now to the left, enter. Above it to the right, enter. 1.640 to 3 decimal places. So that one was totally graphing calculator work there. Now, when we look at the problem, we should ask ourselves really quickly, which I did without saying anything, and I shouldn't do that. I should be saying it out loud. We should take a peek at it and realize we don't know how to factor that. X to the fourth plus 2.09 x cubed. It has decimals. It's an x to the fourth. We don't know what we're doing there. So that definitely would be a graphing calculator problem, even if it didn't say use a graphing calculator. We would need to use the graphing calculator for that one. All right, the next one must be below here. There we go. Find a cubic function with the given zeros. So you have to remember that all of these have come from an x minus h, x minus k, x minus a factor. And it did say a cubic function, so you want to use function notation. And I'm going to put the x plus 7 first. X minus a negative 7 would be x plus 7. And then x plus the square root of 6 and x minus the square root of 6. And I want to go ahead and do the multiplication, the FOIL, on the back two first. And that's because I see I have a sum and difference pattern. So all I have to do is F and L out of FOIL. I don't have to do outside times outside plus inside times inside. It's going to cancel out. So this will be x squared minus square root of 6 times the square root of 6 is the square root of 36, which is 6. And then go ahead and do FOIL again. or file, first times first, x cubed, inside times inside plus 7x squared, outside times outside minus 6x, and then last times last minus 42. So that one was not intended to take a long time. If anybody made a mistake, it was usually, you forgot it was x minus a, x minus h, x minus k. You just forgot that it was a negative in there. Remember, x is always the opposite of what we think it should be, and you'll have it. Alrighty, this one, a rectangular piece of cardboard. Oh, yep. Had to know these were coming. We saw a few of these in the notes. And you did these in Algebra 2 as well. It was 29 by 42. Rectangular piece of cardboard measuring 29 inches by 42 inches is to be made into a box with an open top by cutting equal size squares from each corner and folding up the sides. Let X represent the length of the side of each of those little squares. Okay, put that on there. So there it is. Let X represent the length of the side of each such square. For what value of X will the volume be maximized? So volume of a box is length times width times height. Well, I'm going to do the height first, because when I fold up those little x's, it's going to be x units tall. And then the width and the height, they were 42 and 29, but I have to cut 2 x's out of there. So 49 minus 2x and 29 minus 2x. And then I'd want to go ahead and do the FOIL on the back too. So that gives me 1,218 minus 84x minus 58x plus 4x squared. And combine like terms and turn it around. Put it in standard form. Put your highest power first. So that'll be x times the quantity 4x squared minus 142x plus 1,218. And then distribute the x. And it simply wants to know maximum. Well, all we have to do is put that in the calculator and find its vertex. That's what we have to do. So in the calculator it goes, and I believe I already have that one in here as well. Yes, I do. So I'm going to turn this one off and go down and turn this one on. And again, that's 4x cubed minus 142x squared plus 1218x. So now I'm thinking about the window, and I remember that we had 49 minus 2x and 29 minus 2x. So, and some of you actually found the domain on this one, and you didn't need to, but it really probably was very helpful. I'm just going to leave it 0 to 10 and try it that way. And then if it were, about 40 by 30, that'd be 1,200. So let me try that to start with. And hit graph. Well, I definitely didn't go high enough, and I don't have enough x's. So I will try 0 to 50 and 4,000. There it is. Now, the part that we know we're going to use is going to be that piece of the graph, that interval. And that's because, again, if we messed around with the domain, we would find out what our x's need to be. And we know that the volume can't keep going forever, so that's the part we need. And second, trace number 4, the maximum. And Blinky is where? Blinky is lost. So I'm going to hit my left arrow here until I can get Blinky to realize that I'm looking at this portion of the graph. Left side of the hill, enter. Right side of the hill, enter. Enter through guess. And there it is. So we're going to need to cut those 5.626 inches to maximize our volume at 3070.195. Oh, and this one was multiple choice too. So I was just going to write a sentence about it, and that's what we would normally do if it wasn't multiple choice. And that would be that the cuts should be made 5.626 inches to provide the maximum volume of 3070.195 cubic inches of space. So there it is. And that was the test. So your first step here was watching this and taking notes on it and writing all the work down as you go. But don't forget to go back and do the other steps. And since we are all distance learning now, you're definitely going to want to make a little video to email me. Everything for retakes is done through email, so Schoology is kept for just the initial test that we take, the test number 1, and then all the retakes are done through the email process. So again, once you have all of this done, you can make a little video of yourself flipping through all of the things that you've done, showing all of these conditions have been met, and then we'll talk about when I should open up that test for you.